Alright, John, so we're just going to do another equation, another practice problem. The first one that we did, that was second degree, we solved it by factoring. So we took a look at the equation and we factored it just like what we normally would do to solve an equation. This time, we're going to solve using the quadratic formula because sometimes that's what we need to use in order to solve a, something x squared anyways. So we're just kind of showing you that, hey, look, you could factor it, you could use the quadratic formula, all this stuff that you already know, all this stuff that you've already done for years, you can still use it. The only part that's different is once you get to the end, figuring out all those angles that it's equal to, okay? So we're going to solve using the quadratic formula. To the nearest degree, solve for theta in the interval between 0 to 360 degrees. So this tells me two things. Number one, my answer is going to be in terms of degrees, not in terms of radians. And then number two, if for, by any chance one of our answers is actually 0, I'm going to not just write 0, I'm going to write 0 and 360 degrees because both of those are less than or equal to. Okay. Sometimes you're just going to see 0 less than or equal to theta less than 360. And in that case, if your answer was 0, you cannot include 360. You see how it's not actually equal to it? So just tiny little differences that will make or break you on this test because you have to really pay attention. Honestly speaking, when you take this test, go through for the first time and read it carefully. You need to figure out what your equation is, what your answers are going to be, so degrees or radians, and then what interval it is. So between 0 and 360, 0 and 180, 0 and 90. So go through and solve the whole equation. Once you get to the end, stop, go back up and reread the question all over again. Make sure that you're answering it exactly how they want you to answer it, okay? So this is our equation right here. This is the same thing as x squared plus 2 is equal to 4x. So what would I do in that case? I'd bring that 4x all the way over to the other side so I can set it equal to 0. It's just like any other equation. You have to set it equal to 0 before you can factor or use the quadratic formula. So sine squared theta minus 4 sine theta, because I'm going to bring that over. And I always want to write it in the correct order. So the sine squared first, then the sine, then the constant is equal to 0. Now, I really think that I could factor this. I'm sure I could find two numbers that add up to 4 and multiply to 2. Actually, no, I can't factor that. So you're right, I really need to use the quadratic formula. Some kids would get really frustrated if they weren't able to factor it. So I just had to keep going back and reminding them, hey, use the quadratic formula. So normally we say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But we're not solving for x this time, you're solving for sine theta. Make sure, John, on the test, when you do this, you say sine theta is equal to. Alright, our a is a 1, because the a is out front. Our b is a negative 4, and our c is a positive 2. So the quadratic formula is negative b plus or minus the square root b squared minus 4ac all divided by 2a. So let's do that down here. Negative b, so that's going to be a positive 4 plus or minus the square root of b squared, so negative 4 squared is 16, minus 4 times a, which is 1, times c, which is 2, all over 2a. So 2 times 1, which is just 2. Okay. Awesome. So let's go through and simplify this. 4 times 2 gives me 8, so this is 4 plus or minus the square root of 16 minus 8 all divided by 2. 16 minus 8 is just equal to 8, so this is 4 plus or minus the square root of 8 divided by 2. So square root of 8 is not going to give me a whole number. So you need to write it out as two separate answers. Sine theta is equal to 4 plus radical 8 divided by 2, and sine theta is equal to 4 minus radical 8 divided by 2. Okay, there's two separate answers because of that plus or minus right there. So same thing as before, we have two answers, we got to solve for both of them. So I'm going to put this whole thing into my calculator, figure out what that is as a decimal. Because I got to this point, John, and then I'm going to go back up here and say, okay, solve to the nearest degree, so that's what my answers are going to be, in the interval between 0 and 360, meaning I can have an answer in all four quadrants. So all students take calculus. At this point, though, I'm not really sure if that whole thing, yeah, that whole thing is a positive number, because let's see, 4 plus radical 8, hit enter, and then divide that by 2. You can write this out if you want, you don't have to, but sine theta is equal to 3.414. And then just kind of, you could write that out if you want, or you don't have to. But keep this number in your calculator, because now I know that that's a positive value, so that means I'm going to have an answer in the first quadrant and in the second quadrant. Okay, so sine theta is equal to this. I don't care what sine theta is, I want to know what theta is equal to. So theta is equal to, remember this is to the nearest degree, second sine, second answer. Hit enter. Quit error domain. Oh my goodness, why on earth did that give us an error? Wait a second, I know why. Remember, sine theta can't be bigger than 1 and it can't be smaller than -1. So this does not exist. That theta does not exist. So this won't even give us an answer. You can write DNE, does not exist, and then just move on over here to the next one. Okay? So the good thing about this is when you hit that, it'll, give you an error message and you'll know, okay, something's wrong. Because even I forgot that, oh, that's a 3, so that's not going to work. All right, let's go over here. Let's do another one. Sine theta is equal to, let's figure out what this whole thing is as a decimal. So I have 4 minus radical 8. Enter. I'm going to divide that by 2. This time it's about 0.5857. So that one's definitely going to work because it's between +1 and -1. And it's a positive value. So yet again, I'm going to have an answer in the first quadrant and in the second quadrant. Okay? So then, because this is still in my calculator right here, this decimal, I can just hit second sine, second answer. If you don't leave it in your calculator, you have to write out all of those decimals that you see. Don't hit clear, because you need to write in every single one of those decimals, because otherwise your calculator is going to round it and your answer is not going to be right. We wanted all these answers to the nearest degree. So 35.85, that's going to be 36 degrees. That's one of my answers. That's my answer right here. Now I need 180 minus theta, because my theta is 36 degrees. That was my first answer. Now I have to do 180 minus that. So yet again, you can keep this whole thing in your calculator and just do 180 minus second answer. Hit enter. So this is rounded to the nearest degree, 144 degrees. Okay? So you see how this was only 2 answers, even though it was a a second degree equation? That's why I'm saying, like, forget about thinking about how many answers you're going to have based on what kind of a question. It's really just illogical to try to think about it like that, so don't even worry about it. Try to just figure it out as you go, okay? And remember that you can call me if you have any questions at any time. Alright, let's see. Incomplete quadratics. So what we were just solving were just normal quadratic equations. See how we have the A and the B and the C? We just call these incomplete because we don't have a middle term right there. It's just tangent squared theta minus 3 and sine squared theta minus 1. They're just kind of giving them a name. It really doesn't matter. You just solve the equation. If this was an x squared minus 3 is equal to 0, what would you do? Well, honestly, I would move that 3 over and then take the square root of both sides. So let's see if we can do that. I'm going to add 3 to both sides. Tangent squared theta is equal to 3. But I need to get this tangent by itself still, and I'm not there yet. I need to take the square root of both sides. So I'm going to have tangent theta is equal to the square root of 3. Now the square root of 3 looks really familiar to me. It's from the magic table. Remember how if we have 30, 45, and 60 degrees, and we're looking down at the bottom row at tangent, well, this is radical 3 over 3, which kind of looks like a 1 to me, but it's not because there's that radical 3 on top. So I use that kind of saying to help me remember. So look at radical 3, that is definitely on the magic table. So what's our theta? Theta is 60. But that's not our only answer. This is a positive value, so I'm going to do all students take calculus. Please don't please don't forget to figure out all of the answers in all of the quadrants every single time, John. I don't want you to just say, oh yeah, that's 60 and stop. Here, let me show you how it would have worked even if I typed it in. Second tangent radical 3 would have given you the same answer anyways. I just knew that that was a magic table 1. Okay, so it's a positive value, so I want an answer where tangent's positive. Tangent's positive in the first quadrant and in the third quadrant. So theta is equal to 60 degrees, which is in the first quadrant. And then down here, this is 180 plus theta. So 180 plus 60 degrees is 240. Okay, those are my 2 answers for this equation. Now let's go over here. Sine squared theta minus 1 is equal to 0. I'm going to add 1 to both sides. Sine squared theta is equal to 1. Oh no! Oh my gosh, I just totally forgot something. Now I remembered. Alright, because we're going to have to do the same thing right here. We're going to have to take the square root of both sides, right? Alright, John, I apologize. I forgot something. Whenever you take the square root of something, it becomes positive and negative square root of 3. Oh my gosh, I'm so sorry. Positive and negative. So, instead of just looking for where tangent is positive, you actually are going to have 4 answers, where tangent's positive and where tangent's negative. Oh my gosh. So 60 was our answer in the first quadrant. And then you do 180 minus 60. Oops. 180 minus 60, which is 120 degrees. 180 plus 60, which is 240, which we already found out. And 360 minus 60, which is 300. Well, you know what? Good thing I remembered at this point instead of long time down the road. Alright, I gotta stop and then I'll come right back.